All right, let's talk about the Walras Law. It says that the value of aggregate excess demand is zero. So in this video, I'm going to focus on these three words, aggregate excess demand. I'm going to start off by conjuring up an example, and then we'll take a look at the proof as well, and hopefully that will clear stuff up further. So now keep in mind that we're still operating in our two agent, two good case. So A has, let's say, there are two agents, A and B. So and A has 6 oranges and 3 coconuts, and there's an agent B as well. Um, so now let's just say that A wants more coconuts in exchange for oranges. One way you can interpret that is if A sells his oranges, and then using that money, A can buy those coconuts that he wants. So if A sells oranges worth 20 bucks, then it makes sense for A to buy coconuts worth 20 bucks. Obviously, A can't buy coconuts worth more than 20 bucks, because he doesn't have that money lying around. And to do that, A will have to sell more oranges, and buying coconuts worth less than 20 bucks makes no sense, because then you'll just have money lying around. So what I'm trying to say is the value of how much A wants to buy of coconuts plus the value of how much he wants to buy of oranges should be equal to zero. And that's when we say that the value of A's excess demand is equal to zero. Why is it equal to zero? Well, you can consider the value of oranges to be excess oranges to be negative, because you're trying to sell those, right? So that will be negative 20, and you are buying coconuts worth 20, so that you can consider as positive 20, and both of them will add up to give you zero. Similarly, since we are talking about a two-person, two-good case, we'll have the same thing for agent B as well. And we can say that B's excess demand will also be equal to zero. Now, you see where I'm going with this. If A's excess demand is zero and B's excess demand is zero, and we add those things up, then the demand for both of these goods, the excess demand for both of these goods in our world should be equal to zero. And that is essentially what the Walras law is trying to say, right? Now, hopefully that gives you somewhat of an idea. Let's try to take a look at the proof now, and hopefully it'll be more clear about what these three terms actually mean and about Walras law. Let's start out from A's perspective. On the right hand side of the equation, I have W1A and W2A. That is just agent A's initial endowment or allocation. So W1A is the number of oranges A had, and W2A is the number of oranges, no, sorry, number of coconuts he initially had. And P1 is price of oranges, and P2 is price of coconuts. Or in our case, P1 is price of good 1, and P2 is price of good 2. So you multiply that with the number of units you have, and that will give you how much your initial endowment is worth. On the left hand side of the equation, we have x1a and x2a. Those are agent A's demand functions. So this is the amount of goods that agent A actually wants. X1a is the amount of good 1 he actually wants, and x2a is the amount of good 2 he actually wants. So this is just basic algebra. I'm taking everything to the left hand side of the equation. So over here you have P1 into x1a minus W1a plus P2 into x2a minus W2a. Now let's try to understand what this represents. So x1a is the amount of good 1 A wants to have, and W1a is the amount of good 1 A initially had, right? So x1a minus W1a is actually A's excess demand for good 1, and similarly x2a minus W2a is A's excess demand for good 2. And we are going to denote those excess demand for good 1 and good 2 respectively by E1a and E2a. This is called the excess demand function. So you have P1 into E1a plus P2 into E2a, which should be equal to 0. Similarly, you have it for B as well. It's the exact same thing. This is what you get for B. And now you have your equation 2, and you had your equation 1 as well. We can add them up, and this is what we get. P1 into E1a plus E1b plus P2 into E2a plus E2b equal to 0. Now again, E1a is your excess demand for good 1 for agent A. E1b is your excess demand for good 2 for agent B. So E1a plus E1b is your total excess demand for good 1. and we can also call that as your aggregate excess demand for good 1, and that we are going to represent by Z1. So Z is your aggregate excess demand function, and similarly you have it for good 2 as well. So in the end you get P1 into Z1 plus P2 into Z2 is equal to 0. That is, the sum of your aggregate excess demand is equal to 0, which is exactly what the Walras law is saying. Let's say you're given that your aggregate excess demand for good 1 in your world is equal to 0, that is, Z1 is equal to 0. That basically means that the demand for good 1 is equal to the supply of good 1 in our world. Then you can input this value inside our equation. Then you'll have this is equal to 0. So you'll have P1 into Z1, which is equal to 0, is totally 0, plus P2 into Z2 is equal to 0. And if your price of good 2 is positive, then you'll have Z2 to be equal to 0. That is, if you're given that aggregate excess demand for Z1 equal to 0, or that the demand or supply of good 1 in our world is equal, then that also means that the demand and supply for good 2 in our world will be equal as well. All right, hope you got around that. I'll see you in the next one.